Hi, I'm Kim Tiani. Welcome to Cooler Facts, the show that's full of surprising facts about the world around us. Science, technology, and nature. The first surprise is how we're telling you our stories. Get ready for a fun, fast-paced tour of short little video bits. Each one promises to leave you with something new. Today, you learn how Velcro got its name and how long it takes one drop of water to travel from one Great Lake to another. But first, some really cool facts on roller coasters. Get ready to pull some G's.
We've all felt it. That burst of excitement, the pounding heart, and rush of adrenaline you get from the feeling of falling and losing control. And there are many ways we try to get that thrill. On purpose. One of the safest ways is riding the King to Ka roller coaster at the Six Flags amusement park in Jackson, New Jersey. From a dead start, riders hit a speed of 206 kilometers per hour in just 3.5 seconds. During that acceleration, riders feel a G-force of 1.7 G pushing their faces. That's about half of the G-force the shuttle astronauts feel at takeoff. The coaster climbs straight up 139.5 meters, the height of a 42-story building, then does a quick 180 and dives back down. This hair-raiser lasts only 28 seconds. Film stunts give many moviegoers the same kind of heart-in-your-mouth thrill of falling. The record for the highest free fall from a building without cable or parachute goes to stuntman Dar Robinson in the 1981 movie Sharky's Machine. He ran through a window on the 21st floor of Atlanta's Hyatt Regency Hotel and dropped a whopping 71 meters. That's definitely not for the faint at heart. Skydivers are constantly pushing thrills to the extreme. On a normal jump, a skydiver hits a typical terminal velocity around 270 kilometers per hour. Terminal velocity is the top speed of a falling object without an external force. The top speed may depend on the jumper's weight and body orientation. By finding a less wind-resistant position, an experienced skydiver can increase the maximum speed to 300 kilometers per hour. That rides nearly as fast as an F1 car at full speed, straight down. It is possible to blow that terminal velocity off the charts if you start in the near vacuum of the Earth's outer atmosphere. In August 1960, the U.S. Air Force's Captain Joseph Kittinger stepped off the gondola of a helium balloon at over 102,800 feet. That's 3 times the cruising altitude of a commercial jet. Without any air resistance, Kittinger's free fall quickly maxed out at 982 kilometers per hour, just shy of the speed of sound. He slowed as soon as the air density thickened. But some people have taken a wild leap without any thought of safety. In 1970, a man in San Francisco, under the influence of mind-altering substances, jumped down an air shaft of the Transamerica Skyscraper. Amazingly, after plunging straight down 29 floors, he survived after hitting the concrete floor. He suffered broken thighs, knees, and heels, but no internal injuries. Experts suspected that what saved his life was the increased air pressure in the confined space. It slowed him down. No matter where humans find their big drop, the feel of falling provides a great thrill. And it's mostly free of charge, thanks to the Earth's gravity.
I don't know. I think getting a thrill is one thing, but jumping down an air shaft? Now that's another. I think I'd rather jump in a lake. In fact, in North America, there are 5 great ones to choose from, as you're about to see in these cooler water facts.
Welcome to the 5 Great Lakes in eastern North America. So what's so great about them? Sheer enormity for starters. They hold so much water that if they spilled out over North America, we'd all be waist deep in it. Lake Superior is the largest freshwater lake in the world. Its volume is greater than the other 4 lakes combined, with an additional 3 Eries thrown in. Add it up, and you have more than 1/5 of the world's fresh water supply. The series of lakes is so long and meandering, a single drop of water entering Lake Superior takes some 300 years to make its way through the system. Water flowing out of Lake Ontario today likely carried the canoes of French fur traders in the late 18th century. The Great Lakes are big enough for the moon's gravitational pull to cause tides, though the largest, in Lake Michigan, is just under 5 centimeters. But spectacular fluctuations occur on all 5 lakes. Lake Erie's are the most dramatic, as it's the shallowest. Its levels can change by as much as 2.5 meters. High winds cause some of the largest waves of any lakes in the world. On Lake Superior, swells can reach as high as a 3-story house, hence its status as a storied graveyard to lost ships. The worst of the giant waves are wind setups, when violent gusts push water onto dry land. In the 1960s, one such wave came ashore at Salmon Point on Lake Ontario. Witnesses say the swell forced boats to crash through barn roofs a kilometer inland. That's the same force as some tsunamis caused by ocean floor earthquakes. One wonder that results from all this great water is Niagara Falls. About 4 million liters of water fall every second. In a single day, its gush could fill over 700 billion ice cube trays. That's a lot of ice. Actually, almost 99% of the Great Lakes Basin water is melted ice sheets. During the last ice age, ice 3 kilometers thick covered central Canada. As the sheets moved southward, they gouged out colossal basins. When the sheets melted away, the meltwater filled the basins. They don't call them great for nothing.
700 billion ice cube trays going over Niagara Falls. Wow. Now all I need are 700 billion little umbrellas to put inside those drinks. Next up, get out your calendar and a big red pen. We're gonna tell you what's happening on March 16th, 2880. Welcome back to Cooler Facts. Dinosaurs continue to fascinate us. What would their lives have been like millions of years ago? What I want to know is, would a Hydrosaur be able to break the speed limit?
Considering their longevity, you'd think all the dinosaurs would have been found, but surprisingly, we're still finding these prehistoric hidden gems. Like Triceratops, the world's largest horned dinosaur. This huge vegetarian was the size of a small dump truck. Its skull was as big as a car, and 2 front horns extended the length of a small man. Nearby in North Dakota, scientists identified an extraordinary 67-million-year-old mummified Hydrosaur. Unlike almost all dinosaur fossils, this one retained traces of soft tissue and skin, and that residue has led to new clues. Researchers used a giant CT scanner to calculate the unexpectedly large muscle mass in the tail. More muscle means more speed. Turns out the huge duck-billed dinosaur could run 45 kilometers an hour, at least 13 kilometers an hour faster than the predator T-Rex. Based on complete skeletons, the largest known dinosaur is the Brachiosaurus. It measured 23 meters in length and 12 meters in height, like 2 school buses long and 4 stories high. It weighed the equivalent of 12 elephants. But Brachiosaurus might have had an even bigger cousin in the huge sauropod suborder of dinosaurs. By extrapolating from fragments of leg bones and vertebrae in Argentina, researchers estimate a huge sauropod might have been up to twice the size of its relative. For decades, paleontologists assumed the posture of sauropods meant their long necks stretched as high as possible to eat tall plants and tree leaves. For instance, the Barosaurus was a massive vegetarian with a neck 9 meters long. But that length poses a strange problem. Pumping blood vertically to its distant brain requires intense pressure. After all, a giraffe's heart is the size of a small beach ball and weighs 11 kilos. Based on mammal physiology, the Barosaurus's heart must have weighed 2,000 kilos. That's the weight of a car. But scientists realized that weight would be impossible for the dinosaur's chest size. That knocks out the long-held view that sauropods were hot-blooded vegetarians that nibbled near the treetops. There's a lot of dinosaur history to uncover. If you turned the Earth's history into a 24-hour time span, the dinosaurs roamed from 8 until 10:45 at night, and humans did not appear until the last 30 seconds before midnight. You could say, we are the Earth's party crashers.
So we're the party crashers. Well, scientists say dinosaurs had their party crashed by an uninvited asteroid, literally. Well, since there are billions of asteroids streaking through space, it's a wonder we're not hit every day.
A catastrophic celestial body colliding with Earth isn't just the stuff of Hollywood films. NASA predicts that on March 16, 2880, an asteroid called 1950 DA will get very close to us, with the potential to destroy all life on Earth. The asteroid is about 1.4 kilometers tall, the equivalent of 3 Eiffel Towers. There's a 0.3% chance it will hit Earth, and if it does hit, it will likely be in the ocean, which would cause massive tsunamis worldwide. Asteroids, comets, and meteoroids with orbits near ours are classified as near-Earth objects, or NEOs. These are the rocky leftovers of huge collisions that took place when our solar system formed 4 billion years ago. NEOs could be as small as a grain of sand, or as big as 1,000 kilometers in diameter, about 1/4 the size of our moon. They speed along on average at 25 kilometers a second. That's like flying from New York to London in less than 4 minutes. Comets are bodies of ice and rock formed beyond the outermost planets that have fallen into an orbit around our sun. One of them, Comet Shoemaker-Levy 9, broke up and smashed into Jupiter in 1994. Before impact, Shoemaker broke into fragments. One of them hit with an energy equivalent to 6 million megatons of TNT, about 600 times the entire arsenal of the world. The fireball that followed rose about 3,000 kilometers above the Jovian clouds, roughly the distance between Chicago and Los Angeles. Asteroids have hit Earth before. In 1908, one fell over Siberia. The power of its explosion was about 10 megatons, as powerful as the world's biggest nuclear weapon. It flattened 2,500 square kilometers of land. That's the size of Paris. Many scientists believe an asteroid explosion killed the dinosaurs, and some think an asteroid may have ushered in the Dark Ages. The good news is that modern technology could nudge the orbit of a NEO off course. NASA theorizes that an unmanned spacecraft could hover over an asteroid, pulling it into its gravity, and thereby moving it into a safer orbit. Another deflection strategy: explode a nuclear device nearby, thrusting it off course. This is called an X-ray slap. Clearly, NASA takes the problem seriously. But there's no great panic yet. After all, 1950 DA is still 800 years away. That's a lot of time to fix the problem, and plenty of time for another Hollywood disaster flick.
Well, 800 years is a long time to wait for the end of civilization. Perhaps we should just wait long enough to check out one of Sir Isaac Newton's least known inventions. Here's a hint. Meow. Welcome back to Cooler Facts, a show that opens our eyes to little-known but surprising facts about science, technology, and nature. I'm Kim Jagtiani. You know, I've always wanted to invent something cool, something that would stand the test of time, like one that hasn't changed in over 300 years.
We are surrounded by invention. Sometimes the simpler the invention, the stranger the reason for its creation. Take the humble ballpoint pen. Over 100 million are sold each year. That's more than 3 pens for every Canadian. In 1938, Hungarian journalist Laszlo Biro was exasperated by his fountain pen's ink blotches and liked the idea of using faster-drying newspaper ink. It didn't smudge nearly as easily. Unfortunately, the thick newspaper ink wouldn't flow in a fountain pen. So he designed a pen nib with a tiny ball bearing at the tip. The ball point rotated as it slid along the paper and spread ink evenly. When World War II started, the British government bought Biro's patent. They needed a pen that did not leak at high altitudes. Regrettably for Biro's bank account, he had forgotten to apply for a US patent. He should have written himself a note. And then there's Velcro. Swiss inventor George de Mestral walked his dog in the woods. He and the dog would often come home covered in clingy burrs. He inspected the burrs under a microscope and noticed odd-shaped tiny hooks. In 1955, he developed a two-sided fastener with burr-like hooks and soft loops like his pant fabric. Blending elements of velour and crochet, he called his invention Velcro. Some everyday inventions have endured the test of time. For 330 years, cat flaps have provided a handy way for furry felines to come in and out of a house without letting in intruders. The simple but ingenious flap idea was originally attributed to Mr. Gravity himself, Sir Isaac Newton. But it turns out the famous scientist didn't even own a cat.
Now, one invention that changed the world was the car. There are billions of them worldwide, so you'd think we'd know everything about them, right? Well, what about the car that can beat a Learjet?
We're obsessed with cars, and car makers aim to please by pushing the limits of car design, speed, and technology. The US is the world leader in car ownership, 136 million cars, and that doesn't even include pickups or SUVs. If you lined up all the cars in the US bumper to bumper, you could wrap the equator at least 13 times. The average American will spend 4 years of his or her life in a car. That's as much time as high school. Take a look at this beaut, the largest production car ever made. The Bugatti Royale Type 41 was built in 1927 for an uber-wealthy few just before the Great Depression. The car has an 8-cylinder engine, a 12.7-liter capacity, and is more than 7 meters long. Its hood alone is over 2 meters long. That's bigger than a king-sized bed. Size doesn't matter when time is at a premium. If you've got $550,000 to spare, start up the 2006 British-made Barbarous TKR, the world's fastest street-legal car. The all-carbon fiber body and chassis beast can do 100 kilometers an hour in 1.67 seconds and tops out at 430 kilometers per hour. That's 70 kilometers per hour faster than the takeoff speed of the Concorde. Not bad for 1,000 horsepower. But speed isn't everything. Sometimes parking is more essential. Daimler-Benz's Smart Car can squeak into tight spots and park legally in perpendicular position. It's the smallest car currently in production, measuring less than 2.5 meters in length. You'd need 3 to match the length of the Bugatti.
Oh, imagine fighting for a parking space with 140 million other cars. Sounds like a nightmare come true. After the break, we'll tell you why $200,000 can be a bargain ticket price depending on where you're going. But don't go anywhere just yet. Cooler Facts will be right back. Hi, I'm Kim Jake Tiani. Hardly a day goes by when you don't see a plane overhead. But what about the planes you can see? No, seriously.
Look, it's a bird. It's a plane. Flying machines certainly come in a myriad of shapes and sizes and pack a whole lot of power these days. Like the Airbus A380. This double-decker passenger jet is so enormous it can carry 853 economy passengers. That's the same number of people that can squish into 213 New York taxicabs. The behemoth has a huge range. It can fly from Vancouver to Perth, Australia without stopping. That's 14,800 kilometers. And still, the A380 is a little puppy compared to the Antonov 225, currently the world's largest plane. The Russians built it to transport their spaceships to remote launch sites in Siberia. This beast has a 94-meter wingspan, almost the length of a football field, and it can haul a load of 251 tons, more than the weight of 3 space shuttle orbiters. Other planes try never to be spotted, like the Polecat. It has a 30-meter wingspan and no tail. Kind of looks like a flying wing without a fuselage, like a small B-2 stealth bomber. But this surveillance plane is actually a drone. That means it's unmanned and remote controlled. Designed to be stealthy and sneaky, it flies at 60,000 feet, twice the cruising altitude of commercial jets. To make it as hard as possible to catch on radar, the Polecat is made of 90% composite materials rather than metal. It's even assembled with powerful adhesives instead of rivets. Drones can hover closer to the ground. Police in London, England are testing the 4-rotor battery-powered micro-drone. It can quietly spy from 100 meters above, where it's rarely seen by the unwary people below. It might not be stealthy, but the Ericsson Air Crane is an industry heavyweight with a fine touch. It can place huge hydro towers on top of hard-to-reach, rugged mountains, or can carry 10,000 liters of fire retardant to wash out a forest fire. That's the volume of a large hot tub. If that doesn't heat you up, consider orbiting. As of 2009, Virgin Galactic will offer weightless flights. That means flying passengers up to an elevation of 100,000 kilometers above the Earth. That's the same distance as 2.5 times around the planet's equator. Ticket price, $200,000. Guaranteed a great trip and a steal at $2 per kilometer.
That's it for this edition of Cooler Facts, the show that's full of surprises. Watch for more shows with everything from the world's hottest fires to the coolest stars. The ones in the sky, not Hollywood. So long, I'm Kim J. Tiani. Hi, I'm Kim J. Tiani. Welcome to Cooler Facts, the show that's full of surprising facts about the world around us, science, nature, and technology. Now, the first fact you need to know is that this show has a bit of a different look. Get ready for a fun, fast-paced tour of short computer-animated bits. Each one will leave you looking at the world in a brand new way. Today, have you ever wondered how fast Mach 1 is? You'll meet a sea creature that's over 400 years old and an earthquake so powerful it caused a river to flow backwards. But first, we all know that the Olympics is all about the athletes and Olympic spirit, but what about all that technology?
What with the pressure of all the eyeballs on Earth watching Olympic athletes compete, the Summer Games often push the limits of building and engineering technology. Check out the Sydney Stadium that was built for the 2000 Olympics. At maximum capacity, it seats 115,000 spectators. If for some crazy reason you wanted to stack those chairs, the pile would be almost 69 kilometers high, more than 7 times the height of Mount Everest. Even keeping the Olympic torches lit was a technological achievement. There were 11,500 of them at the 2000 Games, which used a total of 922 kilograms of gas. That's the same amount of propane as 85 gas barbecues. The runners carried the original flame from its origins at Olympia, Greece to Sydney Stadium, a journey of 27,000 kilometers, more than half the circumference of the Earth. The highlight of building sophistication is Beijing's National Swim Center, nicknamed the Water Cube. The cube is made of a steel frame shaped like giant soap bubbles covered with a transparent super lightweight Teflon shell. The result is energy efficient. 90% of the solar energy falling on the building is trapped within the structure and heats the pools and the interior. The pool is wired with monitors that detect the winner by less than 1/100th of a second difference. The naked eye can't help spot the leader. A human blink takes 3/10ths of a second. There are sensors embedded inside the starting blocks and underwater touchpads at the end of the lane. The touchpads are ridged to ensure the swimmer's fingertip, not the force of the water the swimmer is displacing, trips the sensor. The sensors are backed up by cameras that take 100 pictures a second. There's seeing, and then there's tracking. Starting in 2000, marathon runners wore microchips tied to the laces of their shoes. Every 7 kilometers, the runners passed by an antenna that recorded their distance and speed. In fact, the longest race of the Olympics may be more exhausting than you think. The original marathon was set at exactly 26 miles, but during the London Olympics of 1908, organizers decided that the royal family needed a better view of the finish line. They added an extra 385 yards to the race so the finish line would be in front of the royal box. And it's been 26 miles and 385 yards long ever since. 42.195 kilometers. It's unlikely the Olympics will ever move the finish line again for a single person. Too many eyes will be watching. The Beijing Games in 2008 are expected to attract 1 billion people. That's 1/6 of the planet.
Watching those athletes break all those records is probably the best entertainment around. Breaking records, well, that's the focus of our next cooler fact. Breaking the sound barrier. Welcome to a world where a piece of dirt can weigh as much as an elephant.
Ever since we humans have been upright and walking, there has been an eternal quest to be the fastest human on Earth. The Holy Grail is traveling at Mach 1, faster than the speed of sound, just over 1,200 kilometers per hour. That's more than 300 meters per second, roughly 10 times the speed of tennis great Roger Federer's serve. At that speed, you could drive to the moon in about 2 weeks. The place to attempt to go Mach 1 is here, in Nevada's Black Rock Desert. With a surface as smooth as a tabletop, it's the heart of land speed racing. This is where in 1965, Craig Breedlove broke a 960 km/h speed barrier in his Spirit of America, a 3-wheeler powered by a J-47 jet engine. Going Mach 1 in an airplane isn't nearly as dangerous. On the ground, shock waves can launch a vehicle airborne. Traveling that fast, a piece of dirt the size of a quarter and stuck to the wheel rim weighs as much as 700 kilos. Years later, in 1996, Breedlove tried again. He was aiming for a 1,000 km/h cruising speed, and his speedometer rose close to 1,300 k, faster than any car had ever attempted to go. Suddenly, a wicked crosswind struck him, jacking the car up on its forward and side wheels. The wheels acted like a giant off-kilter gyroscope, forcing the vehicle off course. Breedlove was hurtling blind, but he kept his cool and was able to walk away. The good news, he broke the sound barrier. The bad news, it didn't count. Land speed rules require drivers to make the 1.7K run twice. In 1997, Royal Air Force pilot Andy Green stole Breedlove's thunder. He hit the elusive Mach 1 mark in this, his Thrust SSC. It's powered by 2 Rolls-Royce jet engines, producing a total of 100,000 pounds of thrust. That's the power of 1,000 Ford Escorts, or a 747 at cruising altitude. Breedlove's dreams of breaking the sound barrier again went up in smoke. He ran out of money and energy. Attempting to break the land speed record takes genius, courage, and determination. But actually going transonic is somewhere in the realm of the miraculous.
Looks like breaking Mach 1 is going to be one tough record indeed. Coming up, the location of one of the world's biggest garbage dumps, and you'd never guess where it is. Hey, welcome back to Cooler Facts. I'm Kim Jake Tiani. Now, nothing turns you into a recycling enthusiast like seeing a huge pile of garbage, especially if it's in the middle of nature. Here's one that's waterlogged and as heavy as 17 aircraft carriers.
The calming blue serenity of the Pacific Ocean. But look under the surface. Welcome to the giant toilet bowl of plastic. About 1,000 kilometers north of Hawaii, in the Pacific Ocean, floats a mass of plastic garbage that is so big, it has an area twice the size of Texas. Its nickname is the Eastern Garbage Patch, and it never disappears. The garbage gets trapped there because of an ocean phenomenon called the North Pacific Subtropical Gyre. A combination of high-pressure air and clockwise water currents ensnares garbage that floats in and won't let it out. Based on 2007 water samples, there's an estimated 6 kilograms of plastic for every kilogram of naturally occurring plankton trapped in the patch. And there are similar trash traps in other oceans, in the South Pacific, the North and South Atlantic, and the Indian Ocean. We produce around 100 million tons of plastic each year. 10% of it ends up in the sea, and it gets into everything. Plastic sheeting has been discovered in the stomachs of sperm whales. Dutch researchers dissected a seabird that contained over 1,600 pieces of plastic. The problem is that plastic is bio-inert. The durability and stability that makes plastics so useful to consumers also makes them a problem in marine environments. Plastic only breaks down into fragments that end up in the food chain, to be eaten by seabirds and marine life. It gets worse. Not all plastic floats. Around 70% of plastic discarded at sea sinks to the bottom, creating a garbage dump on the sea floor. In the North Sea, Dutch scientists counted around 110 pieces of litter for every square kilometer of seabed. 600,000 tons in the North Sea alone. That's the weight of 17 aircraft carriers. In addition to plastic garbage, industrial runoff like fertilizers or sewage that flow into the coastal regions makes the ocean even more of a deadly garbage dump. The technical term is creeping dead zones. That's what happens when pollution causes the water at the sea floor to become anoxic, meaning it contains almost no dissolved oxygen. What happens is garbage chemicals cause coastal algae to bloom to excess, and they produce oxygen. In response, seafloor bacteria consume all of it and exhaust the dissolved oxygen in the water. It kills the environment for other marine life. One of the most extreme dead zones is in the Gulf of Mexico, where the Mississippi River releases high volumes of fertilizers from the U.S. agricultural heartlands. Another strange item in the ocean's garbage dump is junk that has fallen from space. In 2006, the Russian Progress M56 cargo ship removed old equipment from the International Space Station. Most of the ship and load burned up during re-entry, but surviving fragments fell into the Central Pacific. Called the Spaceship Graveyard, it's the same spot where bits of the Mir space station fell in 2000. In theory, magnets could find and retrieve the spaceship's metal fragments, but there's no effective method to collect floating plastic. It may be a long time before we unclog this giant toilet and return it to a more pristine blue.
Let's hope for a return to that pristine blue. Fortunately, it's not all bad news when it comes to the ocean, especially if you go deep.
One of the greatest mysteries on Earth lies at the bottom of the ocean. In fact, it is the bottom of the ocean. The pitch-black depths of the ocean remain one of the final frontiers. Would you believe there are more maps of the moon than there are of the deep ocean? We've explored only 0.0001% of the deep ocean floor. In 1960, just off the coast of the Philippines, the U.S. Navy used a French sub, the Trieste, to be the first to reach the deepest point of the Pacific Ocean, the Challenger Deep, located in the Marianas Trench. This point of the trench is 11 kilometers deep. That's over 1,400 meters deeper than Mount Everest is tall. These deep waters can expose the ocean to the hot interior of the Earth. In 1977, scientists discovered hot springs jetting out of the ocean floor off the Galapagos Islands. Down 2.5 kilometers, these underwater smokestacks spew burning hot fluids full of minerals. But despite the heat, the water doesn't boil. That's because the weight of the ocean creates such a pressure that it raises the water's boiling point above 380 degrees Celsius. Amazingly, the pitch-dark hot waters are teeming with sea life, such as giant tube worms, lanternfish, pink sea urchins, and spider crabs. These life forms survive by a process called chemosynthesis. They have a way of converting carbon molecules into organic matter. New imaging technology is also revealing how sea life behaves down deep. After 3 years of trying, Japanese biologists finally hooked an elusive giant squid with an underwater video camera in 2005. It was swimming 900 meters below the surface. Before this footage, no one had ever seen a live giant squid swimming in the ocean, so far beyond the range of sunlight. These beasts have only been netted before or have washed up on beaches. And by giant, we're talking big. Giant squids can weigh up to 1,000 kilograms. The largest ever spotted measured a vast 18.5 meters and was found in 1880 off Island Bay in New Zealand. That's the length of 2 buses, but only the weight of a compact car. Every day, the oceans turn up a new clue as to what life is like on the ocean bottom. Scientists think that a clam recently dredged up off the coast of Iceland may be the longest-lived creature ever discovered. By counting rings on its shell, researchers calculated its age at between 405 and 410 years old. This clam was holding court at the time of Queen Elizabeth I and Shakespeare. The previous record age for a clam had maxed out at 220 years. Commonly known as the ocean quahog, the clam's super slow rate of cellular decay may provide clues to the secrets of longer life. We've only scratched the surface of what lies on the deep ocean floor. Who knows what more we'll find in the underwater world of our own planet.
Stay tuned. Even more cooler facts heading your way right after this break. Welcome back to Cooler Facts, the show that sheds light on science and nature by giving you tons of takeaway facts. Now here's a good one. What do you get when you cross a jellyfish with a pig? A piggy fish? A jelly pig? I don't know, but I do know it's just one of many creatures that glows in the dark.
Fireflies lighting up the evening sky are dazzling. Yet in nature, bioluminescence, the ability to glow in the dark, is more the rule than the exception. If you dragged a net in any part of the world's oceans, from a few hundred meters to the surface, almost 90% of the creatures you'd catch would be bioluminescent. Not only that, animals that glow travel in unimaginably large numbers, like the krill. This glow-in-the-dark crustacean is likely the most populous animal on Earth. It swarms in the waters of Antarctica in mobs of 2 million tons per 500 square kilometers. Krill are so prolific, biologists estimate their combined weight is greater than the human population of the world. Animals light up for very expected reasons: to find food, attract mates, and defend against predators. Question is, how do they light up? Bioluminescence is a chemical reaction that results in light without heat. It happens when a protein called luciferin comes together with the enzyme luciferase. Throw oxygen into the mix and you get oxyluciferin, a molecule-sized lantern. It's a favorite party trick of the jellyfish. Of all the jellyfish species, about half are bioluminescent. The most spectacular among them is this feathery, flamboyant creature, the siphonophore. Not only does it glow a fiery red, when under assault, it releases thousands of glowing particles, ones that mimic small plankton that confuse the attacker. Actually, the glow bestowed by nature isn't just pretty. It's lighting up the path to life-saving new discoveries. Which is why in 2006, researchers in Taiwan bred these bioluminescent pigs, created by adding genetic material from jellyfish to a pig embryo. Even their hearts and internal organs are fluorescent. These pigs were bred to study human disease. When the pig's stem cells are injected into another animal, scientists can track the progress of the cells without invasive surgery. Some plants are bioluminescent, including a species of mushroom called Omphallotus nidiformis, or ghost mushroom. It looks a lot like the oyster mushroom, but you don't want to confuse the two. Ghost fungus are toxic, which is a shame. If they were edible, Along with glowing lakes, tides, sea creatures, and flies, we'd have neon soups and omelets. Now that would be cool.
Coming up right after the break, a natural disaster so big it shook Earth off its axis. Hi, welcome back to Cooler Facts. Scientists have spent a lot of time building bombs and creating chemical explosions. But the truth is, Mother Nature packs the greatest punch. In fact, her secret recipe of tectonic plates and molten lava takes the cake.
It's easy to take the solid ground for granted until the odd rumble reminds us just how much power the Earth can unleash. One of the most bizarre results of an earthquake happened in 1811 in the state of Missouri. The magnitude 8 quake lifted up the land so high that it created a dam, causing part of the Mississippi River to temporarily flow backwards. Quakes measuring over 8 on the Richter scale happen on average about once a year. They release the same punch as a 1 gigaton bomb, or 5,000 times the size of the bomb dropped on Nagasaki at the end of World War II. So where does all that energy come from? Well, the Earth is like a pressure cooker, a hard external crust that floats over layers of molten hot rock or magma, ending with a solid rock core under intense pressure and heat. Geologists recently discovered that the solid iron core is actually revolving slightly faster than the surface of the Earth. It's like a planet within a planet. Over 120 years, the core completes one extra rotation. The surface of the Earth consists of large, brittle, 100-kilometer thick tectonic plates. The heat inside the Earth causes the plates to slowly but constantly move. Their collisions create seismic waves or ground vibrations, so powerful that they rip apart the Earth's crust. In 1935, physicist Charles Richter developed a method to measure and compare the magnitude of earthquakes, inventing the Richter scale. Going a whole number higher on the Richter scale is a 10-fold increase in the strength of the seismic vibrations. So while an 8 is strong, remember what a 9.1 can do. In 2004, off the coast of Indonesia, under the sea, a whopping 9.1 strength earthquake hit. It was so big that it shook the Earth off its axis by 1 centimeter and caused ripple vibrations as far away as Alaska. Back at the epicenter, the force of the earthquake caused a tsunami. It displaced a huge tabletop of ocean water. That's what set up the massive waves. In deep water, a tsunami's 30-meter waves can travel 800 kilometers per hour. That's like a 9-story building moving faster than a Learjet. All this natural fury is because of that pressure cooker of molten rock that sometimes blows in the form of a volcanic eruption. Molten rock or magma from as far below as 500 kilometers inside the Earth can seep up through cracks between tectonic plates, building up a mountain of rock. It then spews a volcano. Iceland is the largest volcanic island. Its entire surface was formed by eruptions from the mid-Atlantic ridge of volcanoes. Back in 1783, the Laki volcano erupted with a flood of lava that was 30 meters deep and 80 kilometers long. The worst volcanic eruption happened back in 1815, when Mount Tambora in Indonesia blew out 50 cubic kilometers of magma. It covered 500,000 kilometers of land and sea with 1 centimeter of ash. That's an area the size of Spain. In 1883, the volcano Krakatoa put so much dust into the Earth's atmosphere that sunsets appeared green and the moon appeared blue for almost 2 years. Turns out the tiny 1-micron ash particles scattered red light, but would allow other colors to pass. So the white moonlight shone through the clouds and appeared blue and sometimes green. Nothing stays still for long on this planet. Constantly shifting tectonic plates and the hot liquid core guarantee that there is no such thing as solid ground on this surface we call home.
Well, hopefully we won't be seeing any green sunsets or blue moons anytime soon. But we will be seeing another episode of Cooler Facts. We'll have submarines with swimming pools on them and everything you didn't know about space junk. All done up with our animated twist. Thanks for watching today. I'm Kim J. Tiani.